My name is Sonia, and I'm in Dr. Curtis's Physics 2 course. And a few weeks ago, I went to Dr. Finkelstein's lecture on quantum theory, and I want to share a few things I learned. Um, First of all, Dr. Finkelstein focuses on studying quantum theory, and he started his lecture talking about Einstein's theory of relativity, which is the idea that space and time should be considered together and that they're related to each other, influence each other. And Einstein came up with that theory in the early 1900s, and in the 1920s, Heisenberg and a few others worked with Planck's constant to develop the quantum theory, also known as the quantum principle, which a lot of us would know from our courses like biology, where we studied quantum biology, or chemistry, where we studied spectroscopy, either like IR or NMR for like organic chemistry. And Heisenberg developed the quantum theory, which pretty much said that there are discrete packets of energy and matter, and that maybe we wouldn't consider space and time as related as Einstein had said. And so Dr. Finkelstein talked about some of the research that he and some other people have done to prove the quantum theory. And some of these things included his research on the idea of perfect measurements. So he proved that there is no such thing as a perfect measurement. You can never know for sure, like, if something that you're measuring is indeed exact, like completely concrete. And so he told us about the idea of sharp measurements, where you're making a measurement that you think is exact and you're just going with that. He also talked about the idea of superposition. It kind of goes, he told us that quantum theory violates the Boolean theory of superposition, and this again goes with the idea of exact measurements versus sharp measurements. He said that you can make a sharp measurement using superposition, but again, you can't really prove that you're making an exact measurement. He also went into detail about the idea of entanglement, and that is how we can use sharp measurements to apply the quantum theory. So I thought that Dr. Finkelstein's lecture was really interesting. I think I found it most interesting because he kind of looked into two different theories that were saying different things, and he decided that you can't completely just take a theory that someone says, like, yeah, Einstein was really smart, but how can we just take everything that he said and just assume it's always right? And so Finkelstein was kind of telling us that you have to question some of the theories that are already out there and apply things that you learn and do experiments on your own to determine what is really right, and how can we take what he studied and build on it and go into more detail in the present. And I thought this was really interesting because it made me really think about chemistry, quantum mechanics, and how it applies to chemistry, because I'm a chemical engineering student. And just in my organic chemistry course, we used IR and NMR really often in synthesis lab, and it's just interesting to think how quantum theory was really what helped us explore spectroscopy, and without that we wouldn't really be able to figure out the things that we do today and use spectroscopy to determine different organic compounds that we're working with. And one last thing that Dr. Finkelstein said that I thought was really interesting was he said that the stability of the universe rests on the quantum. And it really just drills in again that so many different aspects of our life depend on the quantum theory and the idea that energy and matter are discrete packets. So that's a little bit of what I learned. So I hope that was helpful. Thank you.